Good evening, folks. Lovely clear evening here in East Devon. And there'll probably be a few of us who are going to have a go at live streaming some of the gas giants and perhaps one or two other things. It's very much an informal event, so please forgive us if things don't quite run too smoothly. I've got 3 computers providing images tonight, all linked up to one another. The weather's playing ball, but technology might not. If I just explain what we've got here, I'm using a Celestron 9. This is a run-of-the-mill, off-the-shelf Celestron 9 with an imaging camera. This is an ASI ZWO 533. It's a color camera. Alongside it is a little guide telescope with a very small camera here. And the whole setup is on an equatorial mount, so it will track the stars, and is being controlled by this little cigarette-shaped box, which is a Raspberry Pi computer, which linked to my iPad in my office, and the iPad is linked to this desktop computer, which is providing these images. So if all goes well, we'll get some live images through this telescope. Tonight, Jupiter is very well placed. This is the southern sky at the moment. You'll see if you go outside and look due south, you'll see the brightest object is Jupiter. A little bit below and to the right is Saturn, and the bright star up above in the Milky Way here is the bright star Altair in the Eagle. The moon is a bit too low for us now. It's beginning to set, so it's out of reach of my telescope, but we should be able to show you the moon in a day or two when it's a bit better placed. Jupiter and Saturn are in this little constellation called Capricornus. Here we have Aquarius. Altair, of course, in the Eagle. And the moon is just off the handle of the teapot of Sagittarius, which is just setting. So, as I speak, we've got Jupiter and the Great Red Spot. This is an image taken a few nights ago, but the Great Red Spot is just rounding the limb of Jupiter. But this shows what sort of detail we might be able to pick up when we take a series of pictures. This is a 60-second video frame, and we stack all these 4,000 or 5,000 images to produce a sharper image, and the various sharpening routines that we use to bring out the detail. And here we can see the Great Red Spot. It's a lot smaller than it was when it was first discovered in 1831. It got very large. It was about 25,000 miles in length through the late 1890s, but it's been shrinking for the last 20 or 30 years. And it's probably now about 10,000 miles in length. Occasionally, you might see a little dark spot traversing Jupiter. This would be called a shadow transit. And this was the shadow transit of Europa. Here you can see little moon Europa just about to leave the limb. The sun is shining this way and casting a shadow of the moon on Jupiter here. Fortunately, no shadow transits tonight. And the other thing we're going to probably have a look at, of course, is Saturn, beautiful ring planet that is just to the right of Jupiter at the moment. And this shows the Cassini division and the shadow of the globe on the rings. Right, I'm going to finish there, and now I'm going to swap to another program. If I can find it.
David, if I can just break in for a minute.
Yeah.
I've gone on to the YouTube channel, the NLO YouTube channel, but I can't actually see anything of your presentation.
Okay, well, I'll tell you what we'll do. This is being recorded, so I'll upload this recording to YouTube when we finish. Okay. Sorry about that. But if there's a problem, we will just have to.
Yeah, I'm not seeing anything live. It's just the uploads.
Yeah. Okay, folks, so here is a live image of Jupiter. If I go to, hang on, I can make it full screen. And I can control it using my iPad. So we're going to move Jupiter down a bit. Here you can see this. It's a bit of a wobbly image. That's what we have to contend with because we're looking through 50 miles of our atmosphere. But you can see a rather oval shape just appearing on the limb here, which is the Great Red Spot. This is still a bit of a mystery. Nobody knows exactly why it is so long-lived, but it's been seen for the last 200 odd years. The Great Red Spot, I'm going to turn off my video, keep my voice going, so you'll be able to, hopefully the bandwidth will last okay for displaying the image. The Great Red Spot is sandwiched between the westward jet stream located along the southern edge of the South Equatorial Belt. That's the South Equatorial Belt, that's the North Equatorial Belt. The belts are dark and the zones are pale. And the eastward jet stream that runs along the northern edge of the South Temperate Belt. So it trundles around anti-clockwise in this direction, rather like a ball bearing in its race. So what we can do now, we can take a short video sequence of this and I can process it later. What I do is I press the big red button on the right, and you'll see at the bottom the numbers, the seconds of the recording. We're taking about 70 or 80 frames per second. And I normally do a video recording about 45 to 60 seconds. And we can process that later. And of course, Jupiter is a giant gas giant, fifth planet from the sun, and it's also our largest. 88,000 miles in diameter, and you get 11 Earths strung out across its diameter. Okay, we will finish the recording there. Press the button. And so that is an AVI saved on the little memory stick riding on the ASI Air Pro, the little computer riding on the telescope. Right, if I now zoom out a bit, now you see Jupiter is a lot smaller, and I'm going to increase what we call the gain and the exposure time. And you'll see the three little moons appearing to the left of Jupiter. And you might say, oh, I always thought there were four moons. Well, the moons you can see are Ganymede, the brightest one on the left, then Europa, then Io, the one nearest to Jupiter. Little Callisto is actually behind the planet at the moment and will reappear in a little while. So let's put the exposure back to 10 milliseconds and adjust the gain. And now we can see the red spot is appearing even a bit more pronounced. The other thing I can do with this setup is I can control the focus remotely. So you can see the little buttons below where it says slow. I can press that and I can either adjust the focus till it appears most sharp. We can go right through the other way. Trouble is, when you start fiddling about the focus, you tend to lose it. Now, the Jupiters are being very wobbly. We call that the seeing conditions. And it's caused by atmospheric turbulence. It does vary a lot. Normally, if you've got a high pressure system and the sky is slightly hazy or foggy, you tend to get reasonably clear images, but maybe that the wind is getting up a bit. Okay, so that's my starter for 10, an image of Jupiter. Alan, would you like to show anything? If not, I'll go to Saturn.
Yeah, I've just been outside to have a look, and it's just solid cloud where I am. I'm just the other side of Exeter, and so I was just downstairs having a look out, and no problem. No chance of seeing anything at the moment.
Right, what we'll do now, I will go into preview mode, and we will tell the telescope to slew to Saturn. It knows the coordinates, so it's slewing to the target position. It plate solves. If it doesn't find it, it will have a second go. And it's confirmed that we're on target. And if I take let's take a short exposure. So what you can see here is a bit of an overexposed Saturn, but you can see, I can see 1, 2, 3, 4, a little tiny moon just underneath it, and 2 moons to the left and a bright moon above it. That bright moon is Titan. And what we can do now, I'm going to stop that, and we're going to go in video mode. We need to increase the exposure to about 18 and the gain. And there we have a live image of Saturn. I'll tweak the focusing a bit. I think that's probably worse. Saturn's a bit lower in the sky right now, so you're going to get more atmospheric dispersion. You can see at the top of Saturn, it's got a bit of a reddy glow and a bluey glow at the bottom. We do have little gadgets called atmospheric dispersion correctors that can correct for that, but I haven't got that fitted this evening. But what we can do, we can take another little short video, press the red button, and off we go. Saturn, of course, is a sixth planet from the Sun and the second largest. So coming up to about 45 seconds, we'll make that do. Stop the clock there. The rings extend from about 4,000 to 75,000 miles from its equator, but they're pretty thin. They're only about 20 meters thick, mainly composed of water ice time. They will gradually fall in back towards the planet. Okay, so that's Saturn. We will go back to the preview mode. What I'm going to do is I'm going to sync the mount so the telescope knows that it's on Saturn. And now we're going to go to the other gas giant, which is Neptune. I hope it's not hiding behind a tree, but we will do our best. And of course, Neptune's a little bit further over in the eastern sky. So it's confirmed it's found Neptune. And what you can see here is a little blue disk right in the center of the field of view. And the little tiny star above it is, in fact, its moon. That's its moon, Triton, the largest moon of Neptune. And of course, Neptune was discovered by Johann Galle from Potsdam, from a position predicted by the French astronomer Leverrier. It's always said that Leverrier discovered Neptune with the point of his pencil. He worked it out mathematically from the perturbations of Uranus, where this other planet should be, and he was pretty good. It was within a degree of his estimated position. Now, we can have a go at video mode, but it would probably be a bit too dim, but we will try. Probably need to increase the exposure and the gain. So that little blue dot there is Neptune. Now here comes Mike Curran. Good evening, Mike. So this is a video of Neptune. We'll increase the exposure. So this is Neptune is, of course, very faint. Well, it's not certainly not as bright as Saturn and Jupiter. You can see Uranus in a pair of binoculars, but I doubt if you'll see Neptune. But what we'll do as before, we'll take a recording. Now, because this is a longer exposure, 76 milliseconds, it's taking a very few frames per second. I'm going to stop it there. I can zoom in a bit more. So let's zoom in. So you can see it's very speckly. That's what we call a noisy image. I can turn the gain down. And you can see the imaging is beginning to deteriorate a bit. The seeing is beginning to deteriorate. I'll turn the gain down and I'll increase the exposure time. I think that's about as good as we're going to get. So we'll take a little recording of that. So unfortunately, it's in video mode. Triton is too faint to record in this video sequence. Okay, we'll stop there. If I go back to the preview mode, so this is taking just single shots now. These are 5-second shots. At the bottom here, we've got a thing called a histogram, and we can adjust these sliders to make the background sky darker. And there's a little shot of Neptune and its moon. And what we can do now, we can, if I go, whoops, stop that. If I go to auto run mode, reset. So light frame. We're just going to take 5-second shots, and we'll do about 20 of them. Little Moon Triton is an amazing world. It has these geysers of liquid nitrogen, and they're causing these dark streaks on the moon. Okay, I think 10 will be enough. We'll Right, it's a nice dark night. So that's the gas giants. Uranus is too far round to the east, so we can't see that yet. But I thought we might try for some deep sky objects with this telescope. If we go and look at just probably about 5 or 10 degrees above Jupiter at the moment, we come to a wonderful globular cluster called Messier 15. So what I'm going to do now is instruct the telescope to go and find it. So this globular cluster is called M15, discovered by Charles Messier. It was 15th in his catalogue of fuzzy objects. He was really looking for comets. And this is a wonderful assembly of stars, probably about 500,000 stars in a tightly knit ball, about 175 light years in diameter. The whole object is about 32,000 light years distance. So it's plate solved. It worked out it wasn't quite on position, so it's having another go. Sometimes it needs a bit more time to think. Okay, I'm going to cancel it there, and I'm going to take a 10-second exposure and see if we're anywhere near it. Yeah, we're spot on. Okay, what we can do now, stop that. At the top right, you can see a little black square. This is our little guide telescope. So I've turned it on. This, of course, a wider field of view, and that fuzzy patch just above the center is, in fact, the globular cluster M15. And I'm going to press the target here. And what that is doing, it's actually guiding. It's chosen a guide star and will start guiding on that little star at the center of the crosshairs. So you can see the little blue and the red trace at the bottom there. That is the little detector moving, checking, keeping the star right in the center of that square. So when it's guiding happily, I will shrink that. You'll see it will remain at the top here. Now this guiding is very important because a lot of the images, or deep sky images, although we were taking very short millisecond exposures for planets, faint objects like deep sky objects require a longer exposure. So what I'm going to do now is go to auto run mode. We'll do 30-second shots, okay. No, actually, we'll go on live mode. And we'll go 30 seconds. And if I press the button, now what we're going to do now is do a stack of this globular cluster, 30-second shots. You'll see at the bottom, it will have the numbers stacked. So hopefully if it's guiding okay, the stars should remain as little pinpoint stars. And the first frame will be coming up. So this is quite a spectacular object. It's not quite as famous or well known as the Hercules cluster, but it is nevertheless pretty bright. There's a little tiny planetary nebula. This is a star that exploded, giving out its material, a little ring right near the center. We probably can't see it, but right somewhere in here is a little planetary nebula called Peas 1. So it's now stacked 2 of the frames. The more frames that are stacked, the darker the background sky should become and the less noise you will see in the image.
It's probably worth stressing, David, that this object is really a very, very long way away from us. It's about 34,000 light years away.
Yeah.
And so what you're seeing there, the light has taken 34,000 years to get to us. And globular clusters are very, very ancient. I think it's about 12.5 billion years old, most of the stars in there, formed right at the very beginning of the sort of star forming processes. In fact, I believe there's actually thought to be a black hole at the center of it, the same as there are in many galaxies, including our own. So there's such a density of stars in the middle. But it's an amazing object, really.
You can imagine being a planet orbiting a star near the center of that, and you probably wouldn't get any nighttime sky. The sky would be completely...
Well, I actually, the amount of light from at the core of a globular cluster is probably not that much brighter in total than the light of the moon.
Oh, really? Oh.
Yeah. I know this because I'm doing a talk on globular clusters on Friday evening.
So we'll stack about 10 of them, and then we'll save that, and then we'll go and look at something else. Another thing about these globular star clusters, it probably don't show up now, but when I process it, you will notice a lot of little blue stars all dotted around it. And those are called RR Lyrae stars, and they're very hot variable stars that twinkle. If you took a series of this globular cluster over the course of one night, you'll see these little blue stars twinkle, rather like lights on a Christmas tree. It was quite amazing to see that. So they have a periods for about 4 or 5 hours from bright to dim. So up here, the guiding is actually doing okay at the moment. I polar aligned it accurately again last night. I have to polar align it about every 6 months. in case, the telescope gets jogged or the mount gets jogged. But so long as you can keep this, the guiding below, these are the seconds of arc, below 1 minute of arc, it's pretty good. Right, we're going to so I think it's saved that. Right, so that object was about 32,000 light years distance. Now we're going to be a bit more adventurous. We're going to find an object 30 million light years distance. Again, it's the same, more or less the same patch of sky as Jupiter, a little bit higher up. We're going to find a galaxy for NGC 891. No, well, let's see what it's found. So start off with just a 10-second exposure. Oh, looks like we're behind some trees, I think. Never mind. Go for a galaxy a little bit more round to the west. We could, of course, slew to Andromeda, but the field of view of this telescope is pretty narrow, so you'd only see the core of the galaxy. You wouldn't see the whole of the galaxy in its entirety.
David, can I interrupt a second?
Yeah, of course, Mike. Yeah.
I'm actually taking a stack on Andromeda at the moment. If you want
Oh,
to
well
have a
done.
look.
Great. We'll just have a look at this one, and then we'll switch over to you.
Okay, you've probably got 10 minutes before I'll have to go out and rewind up the clock.
Okay, well, let's stop there. I'm going to stop sharing, and we'll hand over to you, Mike.
Okay. Right, share main screen.
Oh, wonderful.
Right. Can you see?
Yeah, that's great.
Okay, that's it's done a stack of 22 so far. Round about 30 seconds. Sorry, 60 seconds each. This is a little wind-up clockwork mount I've got, which you can just mount on a standard tripod, and it's just driving my DSLR camera with a 200mm lens attached. Now I managed to connect it into the ASI Air, so I can control it remotely. So I was getting that, but that's a galaxy. It's was it 2.2 million light years away, and it's heading towards us and is going to crash into the Milky Way in about 4.5 billion years.
You can see the dark dust lanes as well.
Yeah, it's beginning to show a few dust lanes and stuff there. So anyway, that was one. I've also got another camera just in the garden, and that's just trying to. It's a fisheye lens, just trying to get a view of the of the Milky Way itself, and that's currently stacked. So
I can see the summer triangle there. Can you point that out?
I can't.
We've got Cygnus upside down. That's
yes, here. Yes,
that's right.
Yeah. Yes, that's right. Yes, and I think this is Jupiter.
Jupiter and Saturn to the.
I think Saturn's there.
That's right.
Yeah.
Great, thanks, Mike.
Anyway, okay, I'll pass it back to you, and let's see if I can find out how to undo the. How do I stop sharing?
Just.
Oh, sorry, got it. It's all right. It was on the other screen. Okay.
Yeah, thank you.
I'll go out and reset the clockwork.
Okay. Right, we're now back on this galaxy NGC 7331. We're going live mode. 30-second shots. And we're going to press the button. So I'm guessing this galaxy, it's called the Dear Lit galaxy. It's about 30, I guess about 30 million light years away, so about 10, 11 times further than Andromeda. But what you will also see is little companion galaxies around it. Right, if I make the sky darker. Right, so this is probably the same sort of size as Andromeda, but you can also see to the right of it, 3 little fuzzy patches, one right over on the right, and then 2 to the left and down a bit. These are little companion galaxies that are all in the same gravitational field as the main object. Now, although you can see the core quite brightly, the spiral arms of this galaxy will extend out to the top and bottom of the field. And I hope as we stack them, the sky will appear darker and you'll be able to see more detail in these spiral arms. We're beginning to see the little dark dust lanes beginning to appear now. You'll also note at the bottom here, the camera is a cool camera. It's running at minus 19 degrees centigrade. The cooler we can keep these electronic devices, the less we call thermal noise, this background noise, will appear on the image. You might notice one or two little red spots. They're actually dead pixels. They're appearing as red little dots on the screen. Those can all be subtracted out by a thing called a dark frame. We would take say, if we're taking 30-second shots, we would take 30-second shots with a cover over the telescope to get a dark frame. And that will record these blemishes, and they can be subtracted out of the final image. You can also go full screen, and we can blow it up a bit. Obviously, the longer exposures you take, the more detail you can pick up. So a good galaxy like this on a dark night, to do it justice, you'd probably take an hour's worth of images, and they might be 2-minute exposures each. So you might do 30 2-minute exposures, and that will allow you to see a lot of the detail in the faint spiral arms. The other thing to look out for when you're imaging galaxies is unexpected stars. Now, all the stars in this picture are foreground stars. However, occasionally you might see one enveloped on one of the arms of the galaxies, which in that case, if it's a new star, it will be a supernova. It will be one star in that galaxy that has exploded. So always keep a lookout for unexpected visitors. The other thing it might be, of course, is an asteroid passing through the field of view, but that will generally leave a trail from one frame to the next. It will move, so you will notice a little straight line trail caused by an asteroid. The other unwelcome visitors we get when imaging, of course, is satellite trails. Unfortunately, with Elon Musk's Starlink array, many of our images are going to be ruined by the passes of this array of satellites. So we've taken 11, we'll take one more and we'll finish there. So there we go, we've saved that one. Right, what I thought we'd do now, we're coming up to the end of our hour. So I'll go back to, we'll switch the guider off. Go to preview mode. And what we'll do, we'll just go back and have a look at Jupiter and notice how far the great red spot would have moved just in the last 3/4 of an hour. Jupiter rotates very quickly, just in 9 hours, 50 minutes. So in the course of an evening, you can observe a lot of the surface of Jupiter. Okay, so there is Jupiter. We'll now go in video mode. Move it up a little bit. Reduce the exposure. And let's see if we can improve the focus a bit. There we go, and let's do a recording of that. And now we've got the great red spot. You can see it's red color right on what we call the central meridian. The central meridian is the very central part of the disk of Jupiter. Amateur astronomers over many years have used what was called central meridian transits of timings of when these features they see transit this imaginary line, and they can work out the longitudes of these objects very accurately. It looks like the seeing conditions have deteriorated a bit. It's all very wobbly, but at least you can see the great red spot there now. So you can see how far it's moved. When we started observing just after 8 o'clock, it was right on the right-hand limb, and now it's moved right to the center. So we've taken a minute of exposure. I can process those and we can show them later on. Okay, folks. Mike or Alan, do you want to show us anything else?
David, skies have cleared a bit where I am, and so I managed to pop the camera onto M31, which you had, but it's still a bit of a ropey image, so it's not one that's really worth sharing. But
would you like to describe what you're imaging with?
Oh yeah, well I've got a 70 millimeter refractor and a 66 millimeter refractor in parallel with it that gets used for the guiding on an equatorial mount, as was David's. I'm using a totally different set of software. David's got his very well integrated ASI Air. I'm a bit more of a traditionalist. I use some software that I've been happy with for several years now. Although I've just downloaded an updated version of some other software just this evening, which I'm going to experiment with in due course. But as I say, the image that I'm getting at the moment is still fairly poor. I used a technique to get an image at all. I used a technique called binning, which is where instead of individual pixels, you group pixels together and I grouped them into groups of 4, which can produce some odd artifacts, but means you can actually. Oh, in fact, another issue, of course, is guiding, which, of course, you've been talking about, David. And one of the problems when it's a bit cloudy is that the star that gets picked for guiding can disappear when the clouds come over. So my guiding has just been lost because the star has vanished into the depths of the clouds somewhere. So it's not a particularly successful session for me at the moment, I'm afraid.
I reckon that's because you're just downwind of Dartmoor, isn't it?
That's right. Yeah, I've been looking at the UK weather forecast for cloud cover, and it was a huge area of cloud just coming off from Dartmoor, which is on the forecast map is mostly drifted away now. But there's still, when I looked outside, there was still enough high cloud that it's really affecting visibility. Sadly, the moon is too low down behind the trees, and Jupiter's behind my garage, so I'm rather stuck with deep space objects at the moment. As I say, I've got an image on screen of M31, but it's a very, very poor one, and so I think it may clear a bit more later on, but I'm not too optimistic, I have to say.
Okay, folks. Well, Alan and Mike, thank you very much for your contributions. We've had our hour up, so we'll finish it there. I'll try and get